Good afternoon and welcome to today's presentation co-sponsored by NABLA Wind Hub. This topic of today's discussion is wind farm redevelopment, maximizing the value of aging and future wind turbines. With me presenting today is CEO of NABLA Wind Hub, Carlo Durante, who should be popping up on the video bridge right now. No, there isn't. Apologies. But we'll continue on. Oh, there's Carlo. How are you?
I'm here.
Thank you for joining us today.
Good afternoon.
Good afternoon. And what we will do is we'll go straight into this presentation. I'll give a quick rundown of this market and why we at Wood Mackenzie are looking so closely into redevelopment of aging assets. This will be a 15 to 20-minute presentation, followed by Carlo, who will be talking about how NABLA Wind Hub can help anybody, asset owners, utilities, IPPs, institutional investors, and manufacturers in solving the complex issues with regards to wind turbine redevelopment. So let's have a quick look. We'll proceed. Firstly, I'd like to talk a little bit about the cost economics of what we would call the lifetime extension activity. For those who don't know the terminology within Wood Mackenzie, lifetime extension activity is typically any kind of activity to keep a project, a wind project, operational beyond the original design lifespan. Typically for most projects aging out now, it's 20 years. Most new equipment now being installed in the ground are expected to last 30 years, but that is our definition of lifetime extension activity. Anything lasting longer than the original design lifetime is considered lifetime extension activity in our books. Let's talk a little bit about the process to lay down the contextual information here about lifetime extension for onshore wind turbines. So really there's many complex and sophisticated solutions being developed for this market. But really what we've seen largely follows along this chain of processes. We can see that in most cases, the lifetime extension activity, a well-designed lifetime extension activity for a project, starts with collecting and optimizing the data for operational equipment. Collecting the operational performance allows people to make the complicated analytics to design a good O&M strategy and upgrade/lifetime extension activity needed to keep those projects viable. There are other factors in place such as site suitability, shortlisting, turbine loads analysis, refurbishment work and upgrade work, and post-lifetime asset management. But primarily, where we see good processes happening is at the very beginning with the data collection and analysis of the operational equipment. One thing that we should go into is what is exactly lifetime extension activity and what does that mean? Well, in truth, as I said before, it is any kind of activity that keeps the turbines operational beyond the original design life. There is no one concrete metric by which this is measured, but we at Wood Mackenzie have seen solutions in this space largely coalesce around these four different levels of activity. We've got on the most simplest scale, level one, basic maintenance, which is continuing on the operations and maintenance strategy for a project to keep the turbine operational in good condition. This is what we would consider the basic run-to-ground strategy, and your costs per turbine can be anywhere from $10,000 to $40,000 per year, with AEP increases from 0 to 2% depending on how sophisticated your maintenance strategy is. Then we start climbing up to more sophisticated solutions such as tip extensions, which is where energy increase, the turbine's energy curve profile is increased by upgrading the blades itself with some form of extensions or remodeling, but not a wholesale rotor replacement. We've seen, of course, AEP increases in this industry from 2 to 6%. Our colleagues at NABLA, who Carlo can tell you, emphasize that we're wrong and that we can see much higher AEP increases. Then we've got level 3 rotor upgrades, which can be anywhere from 200 to 450,000, and comes with some level of aeroelastic modeling to ensure the suitability of the design solution for the original generating equipment. And then finally, level 4, which is something more akin to United States 80/20 partial repowering, complete rotor and drivetrain upgrades. When talking about these solutions, it's always important to talk about the cost economics for the various different levels of lifetime extension activity. Right now, and we'll go into this a little bit later, policies across the world and in Europe don't really have clearly defined carved out niches for turbines operating in a lifetime extended state. But in general, beyond merchant prices, most turbines can still access the PPA market. So a good lifetime extension activity project will also pair with it a favorable PPA to make sure that the capital costs of conducting heavy equipment upgrades is recouped in the short order. We've got a couple of example models down here, GE 1.5 turbines and an Enercon 48 0.8 megawatt turbine in a typical 6 meter per second average wind speed. These are the kind of payback periods that we would expect for the different levels of lifetime extension activity. That can be as low as within the next year to something as astronomically high as 12 years later, depending on the sophistication, energy yield, and the cost of conducting these upgrades. This is why we're talking about this, because with so much equipment aging right now, cost economics will be one of the determining factors on the success of the overall lifetime extension and repowering market. But let's take a look at this market. Since this is a European seminar, let's just specifically focus on the European, Middle East, and Africa regional outlook. A quick look at this market shows that within this decade, the capacity of turbines that have aged out or reached end of life will be nearly 100 gigawatts, or more specifically, 82 gigawatts by the end of this decade. And that is just onshore wind only. Have a look at the left-hand side chart and some of the key markets for end-of-life capacity. Again, emphasizing end-of-life is turbines reaching the end of design life. You can see some of these markets with huge build-outs are in danger of losing wholesale capacity to decommissioning and aging out of original equipment. We keep a close look at the policies in each of these markets, and you can see some of this here. But right now, most policies seem to be focused on repairing rather than lifetime extension. There's nothing wrong with this, but right now, there's a considerable amount of turbines that are not suitable, turbine sites that are not suitable for repairing, and I'll go into this later on in the presentation. This is why policy for both repairing and lifetime extension specific, including market access to tenders, as well as policy repermitting, is vital to make sure we in Europe do not lose 80 plus gigawatts of generational capacity by the end of this decade. If we take a look at the kind of fleet demographics of the European 20 plus year end by 2030, one of the things that we do at Wood Mackenzie is we look at the availability of current and developing lifetime extension solutions in this market. So within the leading platforms, five or so leading OEMs in the European market space, we have been able to determine at least 70% of the operational capacity are running on models that have or can be readily available for lifetime extension solutions. Breaking this down into sub-megawatt versus greater than 1 megawatt, you can see that most greater than 1 megawatt platforms will have some form of lifetime extension solution for those equipment that are aging out by the end of this decade. But for sub-megawatts, it's a harder picture. At best, for most of these OEMs, 50% of operational sub-megawatt platforms do not have a lifetime extension solution. We'll get into why this is an issue later on. This is our current forecast for turbines operating in a lifetime extension solution, lifetime extension state, and for the current installation of repowered projects. Repowered projects, for those who don't know of Wood Mackenzie's terminology, are turbines that are complete replacement of the generating equipment with brand new, typically larger megawatt capacity turbines. Given the kind of slow start to repowering, the lack of decent permitting access, the slow, how should we say, transition to allowing repowered projects across Europe access to the auction tender mechanism, we see more projects going through a lifetime extension state than through repowering, purely because the economics of repowering do not make all projects 100% attractive to do so. So by the end of this decade, we forecast 55 gigawatts of turbines in Europe operating in a lifetime extension state, and only 36 gigawatts having been repowered. Now, what that means for anybody who is a third-party service provider, that 55 gigawatts represents a prime opportunity to provide sophisticated solutions to keep these turbines both technically and operationally viable and economically a positive return for asset owners. But let's dig a little bit further into this lifetime extension forecast. If we go into the demographics of these turbines, we can see that while many of these projects are actually larger sites, 10 plus turbine project sites, a significant chunk of projects are on the smaller distributed scale side, less than nine or less turbines on the project site. And what that means is that there are a significant capacity of projects expected to go under a lifetime extension condition that are not economically viable for more complicated, sophisticated technical solutions, like a tier 3, tier 4 upgrade. And again, it's primarily because these are projects operating on small sites and are sub-megawatt machines. That sub-megawatt machine is quite important in that in many cases, to keep these projects operational, you do need a ready supply of spare parts, especially with capital components and drivetrains. But unfortunately, in many sub-megawatt platform cases, the manufacturing and availability of those spare parts are not there. Let's take a little bit of a deeper dive into the asset owner distribution of these lifetime extension forecasts. In most cases, larger operators who have the capital necessary to deploy lifetime extensions will be able to do so in some form, either by keeping the turbines operational with more advanced maintenance practices or conducting technical solutions to upgrade the equipment. But if you have a look, a large chunk of this market are owned by small-scale community, C&I, or other distributed generation asset owners. And that represents at least 30% by the end of this decade that are owned by small-scale investors. And what that means is that this community will not likely pursue any kind of sophisticated technical solution unless such a solution can be devised for them to keep their turbines operational. These are the community that were the first adopters in this space, sitting on prime wind resource sites close to power demand. And that is a big deal here. When we're talking about lifetime extension and repowering, we've got to keep in mind that a lot of this original capacity that is now aging out were built on these prime sites. And losing this to decommissioning is a bad ordeal for the European power market. I'd like to turn over now to Carlo, who can describe a little bit more what NABLA can do for asset owners, manufacturers, and institutional investors in the space.
Thank you very much, Daniel. So my bit is about maximizing the value of the aging and future wind assets. And I think that this part of the presentation is not just for wind farmers or turbine experts, but also for the wider community of service companies, the financial community, the lenders, the investors. So it's very interesting because it deals with the fact that value can be created in different ways and in different moments of the phase of the life of a wind asset. So first of all, let me briefly introduce to you the Nabla Wind Hub, which is what we have created together with two other partner companies, three partners companies working together since very long with a very wide set of experiences and knowledge on wind assets, on turbines, on measurement systems and methodologies. We were working already, Nabla, Wind Power, Roma Wind, and Netherblades on maintenance, performance improvement, and life extension, providing solutions based on life extension and aging strategy, measurements and turbine health check, and delivering components and solutions which were already making a little bit of the history of the most recent solutions delivered to the wind market, which are called reblading and retipping. This is what we have called Nabla Wind Hub. Unfortunately, the logo doesn't shine in the middle of the page here, but it was desired to be a Nabla Wind Hub. Major thing, which is the combination of these three companies. I think that the message here is anyway that the three entities together show a passion for innovation. This is what we have done constantly over the past 10 years. So we've been innovating constantly until some of our features became industry standards. Methodologies, for example, not just methodologies, also the measurements, the reliability of the measurements and the components that we've been delivering. The results which are executed. So it's not just designing something that somebody else will do. We are doing what we promise and we deliver on promise. And the independence of neutrality, which means that really we can take different inputs and turn them into a very wide array of analysis to come to solve very difficult problems. This is what the Nabla Wind Hub does. And the overall discussion revolves around the fact that what we really believe is that value is not something that just happens, can really be designed from cradle to grave, which means that it can be designed pre-construction. We actually are often hired to design the value of an asset before it's commissioned, before it's constructed, because it can be delivered, it can be designed before the asset enters the operational life, midlife, of course, but also at the end of a regulated life, which means also the certified life. Sometimes regulation and certification go together hand in hand. So this regulation beyond regulated life is also beyond certified life. What is value for us? It's actually a combination of life extension, performance improvement, maintenance optimization, which needs to be very specific. It's not just a generic assertion about this is it. It is very site specific, so it depends on the site characteristics. It's very turbine specific because we know very well the turbines, and it's also relying on our experience, which is models and measurements. The combination of these factors is what we call redevelopment. Now, Daniel said before that about 100, I actually counted above 72 gigawatts of capacity, will reach the 20th year of operative life by 2020 across the European Union. Actually, he said 100, so thank you very much, Daniel. But actually, in the end, the problem is the same. He actually listed something. The typical problem for wind farmers is regulation, unclear, evolving, always changing regulation. Commodity prices, of course, is something when you lose access to the wholesale price and the benefit of the incentive. Commodity prices is something that, of course, is a problem for each and everyone in the energy industry and specifically for wind farmers, also due to the fact that some part of the production is really unpredictable. Access to spare parts and software, the problem of really assessing, being able to assess the residual life, the remaining lifetime. Methodologies are there, but are these methodologies really reliable? Can we count on the experience? Can we count on the actual ability of those that are assisting us in trying to explain what is the residual life? How can that be achieved? Is there any choice that we can make to achieve a specific life extension strategy? And then life extension services, which is both the operational life extension services, but also the financial assistance to life extension sometimes are not ready yet off the shelf for the wind farmer. So the problem is really what happens after a certain period of life in which the asset has been served by typically the OEM in the first part of their life. The older assets instead are typically left outside the OEM coverage, and therefore the non-OEM service increases in the last part of the life of these assets. So in our experience, and this is mainly probably the most relevant message here, is that to maximize the value of aging assets and to future wind assets has to take into account a certain degree of post-warranty non-OEM approach and mentality, which means it is a conscious choice and it has to be designed together between the customer and the supplier. Let me just recap with a chart that I have used already in the past, but it's always very useful. What happens at the end of regulated life? First of all, it really depends on a decision based on a technical and legislative factor, a combination of technical legislative factors. The site could be a good site with good features or not a good site. Technology could be outdated or not so much updated, permitting easy or difficult subsidies, present or not present, commodity prices, volatile, not volatile, difficult to predict or not. But basically 3 choices, which also Daniel tried to explain. First one, which is a no choice, it's abandon, decommission. The site is not good. There is no possibility to deal with permitting. There is nothing else that we can do than to abandon the site. This is, of course, the worst case scenario. Something in the middle, which is repowering, if and when it's possible. It's sites with good resources. It's site with probably optimal layout with the old technology, but the technology is outdated or suboptimal layout that should be changed. So at a certain point within the life of that asset, we can try to change something, but it requires access to capital. So it's full capex and returns are comparable to the new build. Redevelopment is different. Redevelopment is a good site in which we believe together that the technology has still something to offer to the wind farmer. Yes, some permitting is needed, but not that much. Capital is lower, capex is lower than in redevelopment, than in repowering. Returns are typically higher, and the payback is really fast. The focus of redevelopment is always rotor. Rotor is the single main component of the turbine that delivers the highest possible value to an asset. So how do we do this? We have developed a 4-step approach, which starts from understanding what is the site. So this is the assessment. Assessment is a very fast analysis of the features of the site and the model of the turbine, the technology that is used on that site. This assessment tells us what is the possible scenario of the available strategies. It tells us yes or no, there is a combination of life extension and performance improvement that can be executed on this site at a higher level. Then we have to do a deeper assessment, of course, to confirm that there is at least one feasible choice and to detail if that feasible choice is financially sound, technically feasible, and compliant, which is what we call suitability. It's a longer analysis, it's a deeper analysis, but it leads to execution. Execution is where we put in place our solutions. It could be a combination of hardware and software and methodologies. So it could be reblading, retipping, which we will discuss in a minute in the next coming pages, or analytics and measurements. Analytics should deliver the dashboard, the scorecard to be able to control in a very simple way the asset and to predict exactly what will happen by when, and if there are strategies that can be put in place to avoid or to improve the situation because of what we understood on the asset and the site. And finally, after the execution, the fine-tuning, which is really matching against after the execution, matching against the business case. If there is something that we can actually improve after what we have done already, to even go beyond what we had imagined to do in the assessment and suitability phases. This is very important because actually can deliver more value, even more than what we had imagined in the initial phases. And it's a long-term engagement with sometimes our own co-investment in very selected cases, which is what we say skin in the game. And let me go into a couple of examples here. This example is related to reblading, which we have done for some players. This is the example of what we have done for a leading European utility. Reblading is the replacement of the entire rotor with a new rotor, which we have designed and produced ourselves. Of course, when you do this, it's because you have 20 years of history of the old wind farm, which of course means that technology that you're using is old, 20 years, but the design, the manufacturing competencies, the materials that were used, and all that, it's probably older than that. It's 25 to 30 years old. So imagine that we're discussing and we're doing this webinar with 20 or 30 years old computers and communication lines. It wouldn't be acceptable. So imagine that you're doing exactly the same with your assets. What we do is to upgrade and improve the rotor, which, as we've said, is the most relevant component of the wind farm. And this is suitable for smaller turbines. So the oldest ones, the kilowatt turbines, what we have done is for the 47s and the 52s and 58s. In this case, for this European utility, we've defined a set of boundary conditions to be the design inputs. So we've been using the original turbines as the boundary, as the constraint for the design. We've been testing, certifying until full bankability of the new component, which is totally plug and play. We had a very, very strict set of targets that were, the base case that we had to match to approve each one of the reblading investments. The net production increase or performance improvement should have been in the range of 15 to 25%, life extension up to 35 years, and therefore 5 to 10 years average life extension, reduction in OPEX for maintenance and maintenance CAPEX as well. Reblading has been quite successful, I think, and with this specific customer in the example, we are already at the 100 and over 100 turbines which have been rebladed and counting. And I think that the methodology and the approach is really delivering very, very well on promise. And the whole 4 steps have been followed because it's assessment, it's suitability, it's execution, and we are also working on fine-tuning the methodology that we have applied and the blades that we have replaced. If this is reblading, retipping is different. It's typically for multi-megawatt turbines. It's adding an extra 1, 2, or 3 meters to the original turbine. Why 1, 2, or 3? Because this is a flexible strategy. It deals with specific turbine models. The tips that we have developed are suitable for the 80s and the 90s, but it's also relevant to say that it really depends on the features of the site. So if the site is very, very difficult, then we may add only 1 extra meter. But if the site is really generous or maybe with weak wind conditions, we actually could use a 3 meters tip. So that is the flexibility, 1, 2, or 3 meters tip for several types of turbines, which in the end is 9 different types of tips which we have designed. In this case, we are in a stage in which we are completing the analysis for the boundary conditions and testing with our own iSpin sensor and comparing the performance of the turbines pre and post retipping. We are finally in the stages of certification, and we want to reach full bankability. It's again a plug and play solution. It's even more than reblading, site specific because of the flexibility of the multiple tips. It delivers lower performance improvement if compared to reblading, because it's between 5 and 10%. Of course, we try to be more on the 10% side and then on the 5%, and it can be combined with life extension. Let me stress the point that Daniel was mentioning in his chart about tips and rotors, different performance improvement targets, but that really depends on the solution that you're applying. And I think that the real difference with what I am describing and what Daniel was describing is that generic solution compared with the tailored solution. Here we are discussing the tailored solution, which really takes into account not just the component, which probably was what Daniel was referring to, but the component associated with the methodology. So the maximization comes from the full application of the methodology and the strategy that comes from it, plus the component. In this case, we've been even more together with the customer, co-developing, co-investing into the solution, and targeting the retipping on their whole fleet of 80s and 90s. So this is a major achievement also because this is a co-investment. It means that the customer can actually work together with us in designing the solution, and so to reach exactly that fast payback period and IRR that they wanted at the beginning of the discussions we started over 2 years ago. Then delivering value is very typical for M&A cases. And the example that I am presenting here is very simple. The seller's case and the purchaser's case. Actually, the seller's case could actually be retitled as the base case. So what happens when somebody wants to sell an asset is that there is a certain definition of production, life extension, performance improvement potential, and the cost base, which is typically related to maintenance cost and all that. The seller's case in this example was already quite aggressive because this was a major portfolio of several different assets, and the average life was estimated to be 30 years, which was already a little bit aggressive because the typical life would have been 20. So 20 to 30, based on specific service agreements in place. Performance improvement was also let me say, structured and a little bit aggressive because of some agreements with the OEMs, and maintenance optimization was taken into account, but partially, I would say. The ability to work together with the customer, and in this case, the customer was the buyer, was actually to be able to understand that there was a way to work on the majority of the assets to take the initially estimated 30 years of life extension or life target to 40, or to something that was constantly between the average of 35 to 40. Of course, also associating with that, the capex needs, so not just the estimated, let me say, theoretical estimation of life, but also what would that be in terms of retrofit and estimated associated capex. Performance improvements was also much more aggressive because it was not just fine-tuning of the existing components, but adding or replacing. So combination of reblading for those turbines suitable for reblading, or retipping for those other turbines suitable for retipping, which of course increased a lot the performance improvement expectations. And maintenance, in a combination of maintenance engineering techniques and aging management plan, was also a part of, let me say, both cost saving and also adding on top of life extension and performance improvement. So here you really see that redevelopment is really redefining the business case, completely and adding on top of the existing business case a substantial improvement, which is really what we want from what we do in redevelopment. Just let me close my presentation, reminding you that you can find us on LinkedIn, Twitter, and the web, nablawindhub.com. And if you are around Bilbao at the beginning of April, you will find us at Wind Europe. Daniel, Q&A session.
Thank you, Carlo. Thank you for a very enlightening session on NABLA's technology and capability in the sector. For those who want to ask questions, we do have a 20 to 25-minute Q&A session at the end. We have already a lot of great questions coming through, so please send them across. I do apologize if we cannot answer them all, but we will reach out afterwards by email if you have specific questions that need asking. I think I'll start off first. There's one great question that I think is related to how Wood Mackenzie conducts a lot of its analysis, and it's related to permission. Permission required to achieve level 1 to level 4 activity. Is it dependent on countries? I will say yes, it very much depends on the local regulatory authority in each particular country. But of course, Carlo, you have had experience in this area. Would you like to expand upon that? What has NABLA's experience been with obtaining permission to conduct various forms of lifetime extension activity?
Sorry, can you repeat the question? I got a break in the line.
Sure. I was asking, what has NABLA's experience been with obtaining permission necessary to conduct a lifetime extension activity?
Well, it really depends on the countries. Some of the countries, for example, let me give you the example of Italy. In Italy, there is a combination of two things that, of course, saw ourselves pretty much engaged, which are, first of all, the ability to replace non-OEM components on original turbines without the risk of losing the access to incentives. This was something that we had achieved 5 or 6 years ago. Before then, it wasn't possible to replace non-original components on existing assets without the risk of losing access to incentives. That's the first thing that we did. The second thing was actually the ability to simplify the authorization process. So the environmental impact assessment was necessary for all the assets that were changing, replacing parts and components. After the issue of a specific legislation, this was very simplified. And we actually simply said up to 15% rotor diameter, we don't need anymore the environmental impact assessment. I understand that this is very Italian specific, and this is also related to ourselves, to what we did with our customers. This is, by the way, very interesting joint venture, let me say, with the customers. It is more difficult in other countries. I think that Germany is the most difficult country. Spain is somewhat in the middle, and France is somewhat in the middle as well. So in conclusion, I think that it requires a little bit of legislative help to be very effective.
Fantastic. Thank you, Carlo. And I will add that in this market, we certainly do see a need for people who are clever enough to help with developers in the re-permitting process for their lifetime extension activity and repairing, both one and the same. Some other good questions. There's a great question on how to measure AEP improvement, but of course, this is really a case-by-case dependent thing. So perhaps I'll spin the question a little bit and ask Carlo at NABLA, what kind of AEP improvements have you guys managed to achieve?
Well, first, there are two questions here. First of all, is how do we measure? And second, more importantly, what is the real target and achievement? How do we measure? We typically do it with our own iSpin, which is a very reliable, certified measurement tool system and sensor, by the way. It's certified, so we can actually compare apples to apples. We don't fear to put together 2 or 3 different measurement systems, so to be even more sure of the result that we are achieving. So typically what we do is that we understand what is the possible power curve shift, and that is by design. Let me say it's designed by our NABLA Wind Power design team, engineering team. That is by design, but then we have to measure and to see if we are reaching exactly what we wanted. This is what we do testing, live test, so on real turbines. Typically, we do it with our customers, and that means that our customers, with their own tools, measure exactly the same. So if the two things differ, we try to understand what is different, and then we try to come to the same conclusion. So we have typically two turbines, one in pristine conditions, and the second one pre and post redevelopment, let me say, either tips or blades, and we measure the power curve in the three different situations. That is how we measure. The second question is, what did we get? On tips, really, I think that we've been experiencing between 7 to 10%, depending on the cases, but it's too early to say because we are at the early installation phases. I have to be very honest to that. On blades, we've been experiencing even more than 20% on some cases, and on average, on the whole fleet, matching the business case of about 15%. But that really means that we are considering a very wide series of cases. So it's not dependent upon the blades, but it's dependent upon the variety of cases.
Sure, thank you, Carlo. And even though it's case by case, and like you said, it's a very wide measurement here, 15% on average is still very impressive in this market space. That's fantastic. So congratulations to you and the Nabla team. Another good question, veering into the role of OEMs. There's been a lot of great questions about OEMs and the relationship between OEMs and lifetime extension service providers. Let me just, if I may, add a little bit of preamble by stating that we at Wood Mackenzie, we are insistent upon this. These solutions that are provided by many different people, we do not see as competitive, but really successful lifetime extension activity and repowering requires a comprehensive collaborative approach from every stakeholder in this industry: service providers, OEMs, asset owners. But going into the questions, there's some great questions about OEMs. Firstly, perhaps, Carlo, you could clarify this. Could you expand upon, do you mean OEM maintenance is better quality than maintenance provided by a non-OEM supplier in the lifetime extension space, or before that?
Problem is that at the beginning of the life, can you hear me? Yeah. At the beginning of the life of an asset, everything is pretty standard. And then the OEM comes into play because they have to check if their own technology is fitting very well the business
Carlo,
case.
Can you hear me?
Yes, I can. Can you hear me? Can you hear me? Can you hear me, Daniel?
Apologies, we have some technical issues.
Can you hear me now?
Yes, we can now. Apologies for everybody listening. We had some quick technical issues. Hopefully there will be no more interruptions. Carlo, I don't know if you got my last question, but if you've already answered, fantastic. We'll move on to the next one.
I think that the question was on OEMs and the service level. So let me retry, going back. I think that at the beginning of life, OEMs are absolutely key because they are owning the asset. That's the real thing, that they are owning the asset. At the end of the life of the asset, there are certain things that have happened only on that asset and on that technology. So that means that there is a wider array of possible strategies. So the first thing is that it doesn't necessarily have to be the original equipment manufacturer of that turbine that can deal with the asset, because it's more related to the site and how you've been using that technology than the original equipment manufacturer. The second aspect is that it requires a lot more flexibility, and it requires a lot more let me say, preparation and tailoring of the solution for that specific asset. So that's the reason why I think that it has to be much more independent than OEM related. Of course, that doesn't mean that OEMs have not to be involved. I think that a good relationship with the OEM is of essence anyway, but it has to be much more independent than before, and it hasn't just to rely fully 100% on the OEM.
Thank you. One more question on the OEMs before we tackle the whole other slew of questions we've got on here. It's a great question to be asking. Firstly, warranties. How do you view the warranties, and can you provide AdNab a warranty for the services? And secondly, how have the OEMs reacted to this, especially from a warranty perspective, to your lifetime extension activity solutions?
Well, on the warranties, we're prepared to release all type of financial warranties. So yes, we typically do both performance bond or power curve or any other type of standard warranty. That's not a problem for us. I would say that the OEM's reaction is always been very curious, not negative, at times actually very, very interested in what we do. So there is a sort of implicit collaboration, which I think that over time will evolve into an open collaboration. What I'm saying is that typically the OEMs are not disliking what we do, but it certainly requires to accept the fact that when you have changed the rotor, and maybe you want to change the controller, and maybe you want to change also the operating mode of the turbine, what remains of the OEM in the turbine is unclear to me as well. So to say that it really is a collaboration between OEM, if they want, ourselves and the customer.
Thanks, Carlo. And again, emphasizing the point, collaboration. I don't think it's fair to say that anybody is really truly at loggerheads with each other. We all have to collaborate here. Changing tact a little bit, more specific about the technology that NABLA provides. Could you explain a little bit how long does it take to conduct these re-rotary solutions for a particular site and platform?
Well, the initial assessment, it takes a few weeks. The in-depth suitability could take a couple of months. The actual execution of the strategy really depends on the strategy, but in general, tips and blade could be a few days per turbine, but of course it then depends on how many turbines you want to reblade or retip. So it's like months for each of the assets, and it also takes a little bit of time to manufacture the components. But anyway, I would say that months is the measure, and then the long term for fine tuning could really be 3 to 4 years. But then it's after the execution, so it really boils down to what's the agreement between ourselves and the customer.
Fair enough. And another good question here. Could new blades be validated as a replacement for original blades without a particular without the particular purpose of increasing performance?
Sorry, I didn't get it. Can you just rephrase it?
Yeah, could you replace new blades for old without specifically the objective of increasing performance of turbine?
Yes, we could, but then it's a part of the various mixes of strategies that we want to give. Yeah,
that's fair. That's fair. And I guess I would wonder myself personally why anyone would replace the blades and not try to also target an AEP increase.
Well, there could be an answer. That could be an answer. Actually, it could be a subtle question, let me say, because the subtle question is that if we do reblading, of course, retipping is different. But if we do reblading, which is really per se a life extension enabler, we could actually say, let's play with the turbine to achieve the maximum possible life, but not exceeding in terms of performance. Because in the end, it's all about the loads and the stress. You said it in your part of the presentation. It's about loads and stress of the turbine. So if we stress the turbine a little less, and we have the component that allows us to do so, then we're maximizing life, which may be the strategy that the customer wants. That's
Very
why
good.
I'm always stressing this, a combination of life extension, performance improvement.
Very good. And you know what? That segues onto a couple of other questions, all regarded around how can you, at Nabla or anyone really providing the services in this space, guarantee an increase of operational lifespan beyond 20 years. Some have thrown numbers out at 20 additional years to 40 complete years, 30 complete years from design. From an engineering standpoint, how do you also ensure the tower and foundation and all the other equipment is structurally capable of handling these solutions?
Look, I'm not an engineer, but it's a very simple thing. Machines are designed for a certain number of cycles. So if you say in this condition, this machine can work 10,000 cycles, I can say this is done 8,000. There is another 2,000 that are residual life cycle. That is what we can say mathematically, let me say. But it's a question of loads. So if I am able in some way to understand what was the effort, what the fatigue in technical terms of that component, and I am able to save the fatigue, to reduce the fatigue, or to have something that actually helps me in reducing the loads and the fatigue on that component, I can actually have, instead of 10,000, 12,000 cycles for that component. And this is life extension. So there is absolutely no magic. It's about a calculation of what is the work done and the residual work that can be done by a certain component. Our methodology doesn't take into account one single component, but the entire turbine, from top to bottom. And each and every component, from the foundation to the tower section 1, 2, and 3, and then the drivetrain and all that, the gearbox and the blades, are measurable items. So that's very important. We can measure the fatigue, the stress, the loads, and therefore the number of residual cycles for each and every component of the turbine. This is because we combine the knowledge of the physics of the turbine with the knowledge of what happens on the side and what has happened already. That is, therefore, a calculation. This is nothing that deals with assumptions. I am an economist. I deal with assumptions, and I've been making scenarios for all my life. It's reasonable guessing applied to business judgment. In this case, we're not doing this. We're calculating, which is much more precise.
Thank you, Carlo. And during that during that answer, another question has popped up related to what you've been talking about, which is how does Nabla, the team, check the loads with enough accuracy to enable these life extension performance improvement projects?
It's a question again on methodologies and knowledge on the turbine. As I've said at the beginning of my pitch, is a combination of different inputs that allows us to draw from different sources the ability to analyze the complex problems. In this case, we simply drive from what has happened in the past to that turbine in that site, combined with the methodology, with the knowledge of that turbine, specifically with that turbine. So it's not generic. It's because we know the site and the turbine. Let me repeat it again.
Thank you, Carlo. We have maybe at best 5 or 6 minutes left for more questions. Please do send them across, though. If we do not answer them, we both apologize, but we will answer them after this presentation. Another good question, changing tack entirely again, is perhaps on the recycling or wastage front. With decommissioning turbines, we've certainly had a lot of issues with regards to recycling turbine blades. Does Nabla provide a solution for this?
Well, you've seen the numbers, 72 gigawatts for me, 100 for you. It's a major problem. Currently, there is no solution. Let me be very honest. There is no solution at the moment. All of us, ourselves, but also the big names, Vestas, Gamesa, and others, of course, are dealing with this problem. What we are doing is to join forces with others, including the big names, of course, in European projects that are actually aiming at finding a solution for this. Of course, the recycling is the most interesting approach. Reusing is not so interesting, mostly because how many blades do you want to use to make, I don't know, bicycle racks or bridges or whatever. You don't use that many. So that's a problem of usage. Recycling, the problem of recycling, to be very simple in the explanation, is that whatever is the methodology and technology that you're using, the output is so expensive that it's not competitive. So the effort here is that we're trying to find a way to recycle, mostly recycle, with the objective to get out of the recycling process something that is enough competitive for cement or plastic or other composites. Just one point of composite, because we've been thinking, not just myself, but we've been thinking, why don't we do towers for turbines with recycled composite material? It's too expensive. It's way too expensive. Why don't we do blades with recycled composite material? Because we would need to recertify each and every blade because of the new components, because of the new material. So this is not easy, but rest assured that we're all thinking about this problem and we are all very active, not just us.
Thank you, Carlo. One more question before I ask some quick-fire questions, and then we wrap it up. When you conduct a lifetime extension solution, it's not enough just to do them and then walk away. One of the things that is important, his team could recommend what is the kind of service schedule that needs to be conducted, do more blade inspections need to be done, what, in NABLA's view, is the right approach to post-lifetime extension asset management?
Post-life extension asset management is that it needs to be planned a little bit better than before, much more planned, much more programmed. There is probably with our solutions, typically reblading, there is less inspection, less cost associated with managing specifically the blades. And the plan needs to be executed. Therefore, we are able to at least predict what needs to happen by when. So the answer is really not that there is a less or more or different maintenance, but it's that it's really much more planned than before. And it's a very thorough exercise to try to understand if that methodology that has been designed delivers. And if it doesn't deliver, it has to be corrected. So once again, it's about flexibility. And what we say, non-OEM post-warranty approach, is that it requires a mentality that is able to deal with the ever-changing situation of the site and of the turbine in that site.
Thank you, Carlo. And therefore, I can just leave off with saying that for those who are listening and who are service providers in the space, there's a great opportunity for tailored asset management solutions of lifetime extension activity. Just speak to NABLA. Some quick fire questions, mostly on your capability. Does NABLA solution, can NABLA solution also be applied to non-sub-megawatt machines?
We could, yeah, definitely yes.
Fantastic.
Definitely yes.
Offshore machines as well?
We're doing offshore, not reblading, not retipping, but pre-construction life extension, It's a strategy. Pre-construction life extension, but also, it's just because there's no need for offshore wind farms to be rebladed or retipped, but it will come. So we will be prepared.
Fantastic. And then finally, where's NABLA active regionally?
Europe mostly, but also outside of Europe, depending on the cases. Blades are difficult item to travel. Tips can travel. People can travel. Methodologies can travel.
There you go. We'll just leave it off there. We're right on the time mark here. I would like to say thank you all for your participation. I've seen a lot of great questions, and they're still coming through. I do apologize that we haven't been able to get through all of them. We will reach out, both NABLA and Wood Mackenzie will reach out together. And thank you to NABLA and Carlo specifically for joining us today. Carlo?
Thank you very, very much. Again, visit us, LinkedIn, Twitter, the web, or Bilbao. See you next time around.
See you next time.